Today, I'm joined by Professor Scott Draper. Scott is an experienced open water swimmer with multiple Rottnest Channel crossings to his name, and he's currently preparing for another solo crossing in a couple of weeks' time. He has also completed events like the Geograph-based swim and has swum the English Channel as part of a team. Professionally, Scott works at the intersection of engineering and ocean science, and next month he takes on the role as Head of School of Engineering at UWA. His research focuses on understanding how waves interact with swimmers in real ocean conditions. He's also co-investigator and co-founder of the route optimisation tool that many Rottnest Channel swimmers now use to improve performance and, most importantly, safety during the crossing. In this conversation, we talk about what Scott has learnt across multiple channel swims, how his approach has evolved over time, and how his research is helping translate ocean science into practical tools swimmers can actually use. So, Scott, thanks for joining me.
Yep, thanks, Grant. Yeah, honoured to be on here. Thank you.
Before we sort of get into the detail of research and swimming, can you tell the listeners a bit about your own background, how you came to do the work that you're doing, and then potentially how that led into your engagement with swimming itself?
So I work at the University of Western Australia with you, Grant. I'm a civil engineer, so I work in the School of Engineering. I've always been interested in the ocean, so all of my research actually focuses on infrastructure that's in the ocean. Mostly I'm interested in how different structures in the ocean withstand storm events and how they perform over a long time. So, for example, offshore wind farm, all of the infrastructure associated with that, how can we design it to make it stable and work well over its intended lifetime? Equally for things like artificial reefs, which are new and novel concepts that are being developed and designed here in WA and globally. How do we make them stable and perform well over time? So that's my research interest. But in terms of what I do outside of work, I've always enjoyed swimming in the ocean. And it turned out when I was doing my PhD, that I learned a bit more about open water swimming. And there's a number of questions associated with navigation, for example, where a lot of what we do in engineering, thinking about the environment that structures are in and how they behave, also maps across to swimmers. So when they're in the ocean environment, how can we predict or forecast what the ocean conditions will be like? And how do we ensure the swimmer reacts in a way that leads to a good outcome? So there's a little bit of overlap. Lucky in a way because I like swimming. I liked swimming when I was younger, independent of knowing anything about engineering, to be honest. But it's turned out that they do interact and intersect quite well. And so that's sort of where I've got to today.
Yeah, so just from a development of your swimming itself, how did that grow? What are the sort of things that you did? Did you swim at school? Were you doing pool swimming, or was it always going to the ocean?
So when I was quite young, I obviously swam at school. Growing up in WA, I guess that's one of the benefits. We were all sort of exposed to swimming in school, and I also swam out of school when I was in primary school. But then through high school, I guess I was in the late 90s when bodyboarding and surfing were really taking off, and that became a bit more attractive than swimming laps. So that's what I did through high school. I didn't start swimming again until I finished university and started my PhD over in the UK. And I think what attracted me, I was doing my PhD on marine renewable energy, so looking in particular actually at tidal turbines and how they perform around the coast of the UK. And so I was learning a lot about tidal currents, and the English Channel is a location where there are a lot of tidal currents, and it significantly affects open water swims. And so I started to get more into that, and I thought, it would be good to start swimming again, and maybe a good challenge to keep me sane while studying for a PhD would be to be swimming on the side. I thought it'd be good to do that with a group of people, not by myself. So 6 of us formed a team, and then we started training for the English Channel swim, which we successfully completed in 2010. won't tell you how long it took. It took a while, but it was successful. And then I came back to Perth after finishing my PhD. I worked here for a while, and then got back into swimming while I was here, and ran into you, Grant, and since then, I've just been really enjoying swimming in the pool to get better, but also swimming in the ocean with friends. I find open water swimming is a very collegial sort of sport, and the challenge of these long swims, like the Rottnest Channel swim, is really appealing. It gives you plenty of time to think while swimming, but gives you a good challenge to focus on. So that's sort of what's brought me back into swimming here, and I mean, over the last sort of 6 to 7 years that I've been swimming in your squad, Grant, there's been opportunities to sort of swim in most of the Rottnest swims, either in a team or in a solo, and there's a bunch of other really exciting swims popping up, and becoming aware of some of the swims that exist around the world. So it's definitely something I think I'll continue doing for a lot longer. It's got a number of benefits. We can eat a lot over Christmas because you swim a lot, but most importantly, that group of people that you swim with, it's a really great community.
Most people I speak to, even though we're swimming on our own, always tend to highlight that the group dynamics and the importance of having the common goal and sharing experiences, which I'm really fortunate at the moment to be able to do that with you and be able to share your experiences. If we talk about the differences potentially of your first solo swim to sort of where we're getting to now, even if you just compare your first one to the most recent one, what sort of things have changed for you? What have you learnt?
So it's a really good question. I was thinking a bit about the answer to that. I mean, one thing that's definitely different between my first crossing and my last crossing is the time it took. So a lot faster now, but not necessarily because I'm better. I think it's all to do with the conditions. So I was fortunate to be one of the swimmers in 2023 where all the race records were broken, and we were essentially drifting while feeding faster than we would swim some years, I think, because of the easterly winds. And so I think what that's taught me is in open water swimming, you sort of have to go with the flow. You can't control what will happen on a given day. I mean, I also swam in 2024 when the race was called off halfway through. So you can't control what the conditions are like. And I think in a way that's sort of, when you come to terms with that, it's quite nice. You sort of accept that the conditions will be what they are, and what you can do as a swimmer is just adapt as best you can on the day, and it's all part of the experience. So I think now when I first started, I'd probably look at the weather, every half an hour leading up to a swim, a week out. But now I do that less, and quite happy to sort of go with the flow, hope for a good day, but just enjoy the different conditions that we're met with when we arrive on the morning of the swim.
I think that's really important. Everyone, obviously, in an event situation, everyone's faced with those same conditions, and we can't control them. It's really nice to hear that with that experience, you start to understand we can't control it, and the time for some of these events is not as important. For many people, it's about getting across. And it's interesting that those outside of the swimming world might, the first question they say, well, how long does it take? Whereas usually it's, I got there. And so I think that's really important that we do actually appreciate the impact the conditions have on time. And I think we'll cover that in a little bit more detail when we talk about some of your research. So we're going to swim again this year. That's the plan at the moment with about 5 weeks to go.
Yeah.
How are you approaching it this year? Is there anything different? Again, taking on board what you've learnt, have you changed anything since that last swim in 2023?
I think I have. One thing I do in training a lot more now is a lot more long swims. I think for two reasons. One is I can probably do them more easily now, just because of more time swimming over the years. But secondly, because I think originally I would think a 10K swim was a long swim, but it only gets you to halfway in the Rottnest Channel swim. So it makes the second half pretty hard. Whereas, I mean, nowadays in swimming training leading up, we'll commonly do sort of 15, 18K swims just to give us that confidence that, when you get over halfway, you do have a lot left, and just building endurance through those longer swims as well. I think the other thing that I sort of focus a lot on now is a constant speed. So over those 18K sessions, can I keep the last 3Ks reasonably similar in speed to the first three? And that sort of comes a bit out of the research, right? A lot of what we do, especially for the Rottnest Channel swim, sort of shows, the second half of the swim where the currents get stronger. It's particularly important to hold your speed if you can. So training in a way that I want to sort of swim the actual race, if you like.
Yeah. So we'll transition a little bit into that research side of things. First, I'd like to just discuss the research that you've undertaken relating to the impact of waves on swimming. We'll talk about the route optimization tool after this, but what sort of questions did you have and what were you trying to solve through that research?
So the truth is that I guess fundamentally, obviously swimming in the open water, one of the main differences is there are waves present, whereas in a pool, there is also waves, but only generated by swimmers near you, and the lane ropes tend to damp those out. So obviously in the open water, there's much bigger waves. And so I've always been interested in what those waves do to your performance as a swimmer. So how fast or slower, how much more quickly or slowly you can go with and without the waves, and also what they do to your behaviour. So how do they affect your stroke? And I think we got lucky at UWA. We were able to refurbish one of our wave flumes that's located at Shenton Park, one of the campuses that UWA has. And that wave flume is just over 50 metres long, 1.5 metres wide. So it pretty much looks like one lane of a 50-metre pool, except we've got wave makers on both sides, so we can generate a range of different wave conditions to replicate what you might encounter in open water. So what we thought, and I think it wasn't just me, it was sort of me, you, Nat, and Terry as well, thinking, this is a great opportunity in a controlled environment to look at how we can generate waves and then put swimmers in the flume and see how they perform and how their behaviour changes. So that's sort of where it all started. I think some of the key questions that most interested in solving to start with were, how much slower do you go swimming into waves, so when waves are propagating towards you, and how much faster could you go when you swim with the waves, when you sort of try and surf them, if you like, as they come from behind and then propagate past you. So they were the main questions, and there's a host of other questions as well. And we've spoke about these, Grant, a lot, and hopefully it will keep us occupied for years to come. But questions around, do tall swimmers benefit more swimming into the waves because they've got more stability, perhaps, or the waves have to be bigger before they affect them? Is there different drafting strategies you might adopt in wave conditions to still water? Do you expend more energy swimming into the waves? So perhaps you should draft on a leg of a race where you're going into the waves, and then when you're going with the waves, maybe you should take a turn at the front. So there's all these sort of questions that follow on. But I think the fundamental one was, how does it affect performance and behaviour? And those two examples of what happens with the waves and against the waves.
So if we look at some models, you've created and estimated the impact in terms of velocity. How do we maybe at this point in time, as you said, there's still plenty of questions to ask, in terms of giving something meaningful to swimmers? Is there something that they can take away at the moment?
I think one thing that's been really clear in our work so far has been that it's not necessarily the height of the waves that matters. So you could have 1 meter waves or 3 meter waves. The difference there is not necessarily what's important. What's important is the wave steepness. So the height of the wave relative to its length. So I think what we've found is it's really steepness that is the key parameter that influences your ability to swim effectively. So what we've seen in a number of our flume experiments is when we reduce the wave period, which basically makes the waves steeper, these short, steep waves, they become really hard to swim through, and we start seeing speed drop, typically on the order of 10 to sometimes 20%, depending on how experienced the swimmer is that's in the trial. And that's a significant drop. And so what I think we would want swimmers to take away is that you could expect, this 10 to 20% reduction in speed when you're swimming in waves that are steep. And so if you come out and your time is, 10 or 20% longer than normal, that's okay. I mean, that's just the response to the waves. I don't think we've done enough to start giving swimmers strategies to minimize that, except perhaps if you have the ability to choose your route a little bit, because of that steepness effect, what it says is if you can at least go at an angle to the waves rather than going directly into them, you'll make the waves less steep, and that will be beneficial to your forwards motion. But yeah, I mean, that's sort of where we're at the moment. I think a lot more could be pulled out of this work as we go forwards and learn more.
So if we sort of take that and move towards the route optimization tool that you played a really large role in developing, and it obviously has gone through a few iterations, and one of those at the moment is still trying to implement the wave part into the model. Can you just give a bit of a background on how this tool came about?
Yeah, so this was back when we first did a rot nest swim, actually. So we were doing it as a team, and we were thinking about, because we're engineers, we're thinking about how to engineer the swim in a way that we could improve our performance. So we were doing all sorts of things as a team, actually. We were trying to work out what the optimum swimming time is for each swimmer before you change over. And we knew that it should be very short, so you don't get tired. You can essentially sprint maybe 100 meters and then swap over. But we also realized there's an energy cost with getting in and out of a boat. So we were trying to work out what is the optimum sort of swimming time. So that's where we started, and we thought, okay, well, what else can we control? And we had a look through the race rules, and we realized, okay, there's a emergency corridor to the north of the route, which you can't cross and go into. But there was no constraint to where you would swim south of the route. So you could go as far south as you like back in those days. There was no exclusion zone or anything to the south of the run line. And then we started having a look at what the typical currents were like. And it's not the same every year, but more often than not, when the sea breeze comes in, there'll be a reasonably strong current from the south to the north, close to Rottnest Island. And we thought, okay, well, that's going to want to push you north when you're getting close to Rottnest. So rather than being on the run line at that point, it might be better to be south of the run line. So you let the currents push you back onto course rather than you have to fight the current to stay on the course. And so we said, okay, well, let's now start to do some engineering, and we can get the current forecast out. We can treat swimmers like particles moving through the ocean, but with a forward speed. And we'll start to try and think about, okay, what is the optimum path that they should take to get from point A, Cottesloe, to point B, Rottnest Island, in the shortest possible time.
That was obviously your first little foray when you were with that team, and then it became a bit more formalised. So where are we now with this tool, and who's using it, and how does it actually benefit the swimmers?
So I should mention Terry Griffiths. He was a PhD student at UWA back then. He now leads an engineering consultancy designing wind farms, which we'll talk about at the very start of the podcast today. So Terry and I would use that route optimization algorithm that we wrote, and we would be the only people using it to begin with. So we would be often 1K to maybe 2K south of the fleet during the swim. We'd often have the race boats come up and ask us to, if we're okay, if we know where the route is. To which
where's the island?
And if you know Terry's not shy in telling them, why we're doing this. And so that was the start point. And then in 2021 was a year where the currents were particularly strong. They were up to 1 metre per second near Rottnest Island. And a number of swimmers, I think in the end, probably 50 or so swimmers had to be pulled from the water because they drifted north into the emergency corridor, and they're not allowed to stay there. So if they couldn't swim back onto the route, then they would be pulled from the water. Swimming against the 1 metre per second current is very hard, especially towards the back of the fleet. That's probably the speed the swimmers will be swimming at the start of their swim, not towards Rottnest. So they had to be pulled from the water, and that's a safety concern. You don't want to have 50 swimmers drifting into emergency corridor, and it's also not ideal for those swimmers. I mean, many of them were capable of making it to Rottnest, but because of the conditions and the route they took, they weren't able to. So after that, we were approached by the Rottnest Channel Swim Association. I think they remembered that we were 2K south of the route and asked us a bit about what we were doing and if we'd be willing to work with them to come up with a tool that could be used by all swimmers that register for the swim, and also used by the swim association themselves, the Rottnest Channel Swim Association, to get a feel for how swimmers may disperse during race day and where swimmers might be at different times during the swim. So we did that, and we launched that in 2022, and we are able to track the number of calculations that are done. I think in 2022, leading up to the race, we had about 100 or so calculations, which were probably all me trying to debug the algorithm. But then it went hot a couple of days before, and in the end, I think we had about 10,000 calculations on the app, which is great. It means there's not 10,000 swimmers, so it means people are playing around with it, trying out what different paces and different feed strategies might do to their route. So nowadays we've run it for the last I think this will be the 5th year this year coming up, and each year we get about 10,000 or so calculations, and from all sorts of swimmers, from groups, the teams, right through to duos, through to solos. We are always on the lookout for feedback, so we're keen to improve it. As you said, Grant, at the moment we don't have waves built into the main algorithm that's made available. So all it's accounting for is the currents, and in many years the currents can be the dominant factor. So 2021 is a good example. 2023 is another good example. But in other years, like 2024, the waves are really important. So we're working quite hard to get the learnings from the flume experiments encoded into the app going forwards.
Cool. So if swimmers are, as you say, they're putting in a lot of calculations, potentially what are some of the mistakes or the misinterpretations that the swimmers might have with the output?
I think that the trickiest part, so the way the app works is you put in your pace, so essentially how quick you would swim over 20 Ks if there were no currents. And then what we do is we take that pace, which is your swimming speed, and we combine that with the forecast currents, and we work out sort of what your optimum route is. That pace is an important parameter, because if you're really fast swimmer, like your pace is very high, much higher than the background currents, then your optimum route is just to go from A to B in a straight line. The currents won't influence you at all. You're so fast that they don't affect you. At the other end of the spectrum, if you're swimming at a similar pace to the currents, then your route becomes really important. And at any point, if you have to fight the current, then you're not going to be able to, because you can't swim quicker than it. So the pace is the key thing, really, for the app. I think at the moment we have a webinar before each swim, and we talk about how do you determine that pace. And often the way I think people determine the pace is by using their 10K qualifying swims, which are also influenced by currents and waves, but often those courses are lap courses where you're just going around in a lap. So hopefully any of those effects average out. You might spend half your time going into the waves, half your time with the waves, half your time into a longshore current, half the time with a longshore current, but on average it's hopefully averaging out. So I think getting that pace right is the key. If you don't get that right, then it's not going to give you a good prediction. I think the other thing to probably mention is the app sort of does two things. It gives you an optimum route and tells you how long it'll take you to swim on that optimum route, and it also gives you an idea of how long it would take you to swim if you were to swim on the run line as well. And if you use it, you'll see the optimum route's always faster, and how much faster depends on the forecast currents, really. But both of those outputs, I think, are really important, and maybe people the most benefit they get from the app is actually those estimates. So we talked earlier about going with the flow. Every year is different, and the conditions, you can't control them. So what the app will do is it will give you an idea about whether this is going to be a year where you're going to take 6 hours, or you can maybe get 5 hours, or or maybe it's going to take you 7 hours. And I think knowing that is really important, so that when you're out there on the day and you get to halfway and you're like doing a quick, doubling your time to work out how long it's going to take you, hopefully that's not a surprise for you at that point. You realize, it's going to be a 7 hour swim. You get to halfway at about just over 3 hours and you realize, okay, this is all going to plan. And so mentally, I think that's really helpful for you when you're out there, as opposed to, thinking you could do 5 hours, getting to halfway just over 3 hours, and you start going, oh no, this is going wrong. So yeah, I think using the time is something that I think many people do, but it's also a good advantage, a good output from the app itself.
Yeah, and I think as you indicated, the safety component of that certainly is highlighted. It's great for the swimmers and their team to know roughly where they should be and how long it will take, but also knowing if I'm going to be in the water for an extra hour potentially, how do I modify my nutrition? How do I think I'm going to deal with the cold? There's a lot of other bits and pieces that certainly do help with that safety component too.
Yeah, definitely.
You're sitting at this. I'm an engineer. I work in ocean science. I love swimming. Which hat do you wear at what times? You come with experience as an engineer and go, oh, this is the way we should do it. I've got some experience as a swimmer, and I think this might be the right way. What are some of the things that you might find challenging about that?
Yeah, so I'm an engineer. So first and foremost, I like swimming, but I'm definitely not good. So I think what I have to be careful of whenever I'm planning a swim is making sure that if I'm approaching it in the way I do, and start wanting to optimize and do calculations, making sure I talk to people like you, Grant, about, okay, is this sensible, from a swimming perspective. So I think that's important. I think one thing that's been really fun from the perspective of doing this research, as with a lot of research, is that we do it in a team, and it's an interdisciplinary team. And so my expertise is working out how structures respond in the ocean, and the swimmer is a structure. If you want to go to that length of sort of trying to idealize the situation, but of course a swimmer is complicated, and the biomechanics of swimming, the nutrition, as you just talked about, hypothermia. These are all really interesting and really important aspects of open water swimming that I'm not an expert in. So I enjoy working with you and with Nat and with others to think about where we could take this research to have a real benefit to swimmers. If we don't take these things into account, then we're not really modelling the right problem, and the outcomes won't be anywhere near as helpful.
So just on that, where would you like this research to head, or what would you like it to be able to do or achieve?
Yeah, good question. I feel like there's improvements we could make to what we already have. I think including the waves is particularly important. One thing we haven't been able to study in our wave flume is the effects of swimming in waves for a long time, because we only have a 50-meter long flume, and if you're swimming into the waves, you basically have to swim from one end to the other, and then walk back and swim from one end to the other. So we can't really do long duration swimming in the flume. We know waves will probably have a fatigue impact on you. I mean, anybody that's swum in the waves knows that you're a bit sorer afterwards than what you would be if you swam in flat water. And so I think we're really keen to continue what we've been doing and try and embed the effect of the waves into that route optimization. The optimum route with waves included may look very different, so that you avoid having to swim directly into the waves and fatiguing and slowing down later in the swim. So I think that's one thing I'd love to continue to do, and hopefully be able to include that later. I mean, the second thing is, when you do open water swimming, you're immediately drawn to all the different swims that exist around the world. And there's some fabulous swims, the Ocean 7, which Andrew Donaldson has completed, and watching him do all of those has been really exciting. And you think to yourself, okay, well, all of those swims have the same types of challenges that the Rottnest Channel swim has. Some of them more so, some of them perhaps a bit less so. But I get excited about the idea of whether we could use some of our oceanographic modelling to better understand those swimming environments, and use similar approaches to what we're trying to use for the Rottnest Channel swim, to make those swims more successful for the average swimmer. I'd love the idea of trying to see if we could get more records broken by using this type of approach as well. And it's going to be, I think it would be a journey. I mean, I know the English Channel swim is one that I know a bit more about because we did that 10 to 15 years ago now, but it's still similar in the sense that you have pilots that take you across, and those pilots know a lot about the conditions, and there's a lot of anecdotal understanding about the tides. So being able to work with them and use our current state-of-the-art models, which can model the ocean at finer and finer resolution, and see if we can sort of corroborate their intuition and their experience, and then work together to try and fine tune and make those swims more successful.
It's really interesting, as you say, to look at how can we do this and apply it to other swims around the world, especially with those swims that have large current, and how, and if we understand the wave conditions too, how they might impact it. Because if we can reduce swim time, obviously everyone's happier. Because a lot of the bigger challenges, especially some of these other swims, in these ocean sevens, the water temperature is a lot colder than what we experience in Western Australia. So reducing that swim time and therefore the safety as well. So just closing out now, if you had a bit of advice for someone planning their first roto swim, what would it be?
Yeah, I think the most important thing with your first Rottnest swim and any Rottnest swim is having a good team. So you'll have a skipper. You may or may not know the skipper, depending on your circumstance. But important to obviously meet up with them and talk through what's going to happen carefully. But then ideally you'll have a kayaker that you know well, probably 2 kayakers and a support person on the boat. I think those people are particularly important. They need to know you so that if there are issues with hypothermia or anything else, they will know if there's a problem. So that's really important from a safety perspective, but also from a motivational perspective and from an enjoyment perspective. Having a kayaker there from start to finish that you know really well and goes through the adventure with you makes it all the more worthwhile. So they'll motivate you, they'll keep you going, they'll keep your feed breaks short and not let you take too long. They'll guide you in and out of trouble, more out of trouble than into trouble, hopefully. Yeah, and they'll be there for you the whole time. So I think getting a team of people that you know well and practicing with your kayaker is important too. They're the things I'd recommend most for a first-time swimmer.
Yeah, I think it's really important, the feeding part, especially with a solo. As you said, getting you out of trouble. Again, I think that's an area where that navigating, even though we've picked our route, there's still other swimmers, there's other craft that we do need to navigate, and the swimmer being low in the water can't always see those things. So that support from the skipper and from the kayaker is certainly very important.
Your last question is, what is your favourite swimming session?
So I love the sets where we have to do different speeds within the set. So anything where we have to do like a rolling 25 in 100, so we're doing, I don't know, maybe 10 hundreds, but in each 100 there's a 25 we go hard and the other 75 we go race pace or normal. I really like those. They keep you mentally alert. So anything like that. I also really like, big fan of the Monday sessions where we're doing more distance, more aerobic. Definitely prefer those.
Awesome. And is there anything else you want to share before we sign off?
Yeah, I think we've spoke through most things, Grant. I think probably 2 things maybe. I mean, one would be, if anybody's interested in the route optimization in particular, please do reach out. It's some research that we would love to progress, and it's really the type of research we would like to do openly. So the more people that are interested and involved, the better it will be. So that's something I'd love to say. If anybody's at all interested, just get in touch and happy to talk about it more. I mean, I would like to say thanks for this opportunity. I've swum with you now, Grant, since I think 2018, and yeah, I mean, I've gained a lot from those sessions and from all of your advice along the way. So if you're listening to this and you don't currently swim in a squad, but you like swimming, sign up in a squad because you get exposed to that community. You'll have a great, trainer, and you'll improve, and you'll also enjoy it a lot more too. So, yeah.
Awesome. Look, the main reason for doing this podcast really is about sharing information and allowing not just the swimmers to gain from this, but hopefully those that are involved with the research, and how can we then apply that to swimming. So anyone who's interested, I agree, if they want to engage, then we're more than happy to have some conversations. Well, I'd again like to thank you for taking some time to talk to me today. I'm really excited about the research you're doing. Good luck with your new role as head of school. And best of luck for your next Rotto swim in a few weeks' time. As you've indicated, you've certainly grown over the last 7 years or so, and it's really good to see how calm you are and are ready for the event.
Yep. Thanks, Grant.
Thanks again, Scott, for taking the time to share both your swimming experiences and the work you're doing at the interface of ocean science and ocean water swimming. One of the big takeaways from this conversation is the conditions of the channel are never static, and understanding how waves and currents interact with the swimmer can make a meaningful difference, not just to performance, but to safety as well. If you're planning a Rottnest Channel crossing, it's well worth spending some time with the route optimization tool Scott has described. Used properly, it can help you think more clearly about your line, your preparation, and how conditions on the day might affect your swim. Used properly, it can help you think more clearly about your line, your preparation, and how conditions on the day might affect your swim. At the time of publishing this episode, Scott is unfortunately without a boat. If anyone can help, please reach out. As always, if there's someone you think I should talk to on the podcast, please let me know. If you enjoyed this episode, please consider sharing it with someone in your swimming community. Thanks for listening, and I'll see you in the water. A special thanks to Lily Landers, who has recorded the waves you hear during the episode.